This is Algebra 1, Section 13.4, Multiple Event Probability. So in this section, we're going to be talking about how to find the probability of more than one thing happening, either at the same time or one or the other. So what is classified as an event? An event is just anything that happens, anything that we're trying to determine the probability of. So if you have a six-sided die and I say what's the probability of you rolling a 3, you rolling a 3 would be the event that we're talking about. So two main rules. We've got or statements and statements. Okay, so an or statement would be like if I say, what's the probability of you rolling a 3 or a 4? So when we have a situation like that, it's going to be, we're going to take the addition of the individual probabilities of whatever events we're talking about. Probabilities. Okay, and we're also, this part is important, we're also going to have to subtract any overlap, and we'll talk about what that means in a second. Okay, if we have an and event, so if I ask what's the probability of two things happening at the same time, then we're going to have the multiplication of the individual probabilities of those events. Okay, so or statements mean addition and statements mean multiplication, and we'll see examples of this down below. So first example is we have two balanced die. That just means there's an even chance of every number coming up, 1 through 6. Two balanced die are rolled. The possible outcomes are listed here. So rolling a 1 and then a 2 is different than rolling a 2 and then a 1 because we have two die. So if I roll the two die, then the first one could come up 1 and the second one could come up 2, or the first one could come up 2 and the second one could come up 1. Those are two different events. So if I add up all these total possibilities, they're all listed out here. There's 36 total possibilities. Okay, so we're going to look at these different events. Event A is that you get a pair. So let's count up how many possibilities are a pair. Well, I could have a 1 and a 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, or 6 and 6. That's 6 pairs. So there's 6 options, or 6 ways that event A could happen. Event B is that both numbers are odd. Okay, well here I've got two odd numbers, here, here. None of the 2's, because 2 is even. Could be 3 and 1, 3 and 3, 3 and 5. None of the 4's, because 4 is even. 5 and 1, 5 and 3, 5 and 5, and then none of the 6's. So counting that up, that's 9 options for both numbers being odd. Event C is that 3 is one of the numbers. So right here, we've got 6 options. C is one of the numbers, or 3 is one of the numbers, sorry. 3 is one of the numbers, 6 ways here, and then I've also got 1 and 3, 2 and 3, 4 and 3, 5 and 3, 6 and 3. So that's 5 more options because we don't recount this one because we already counted that one. So we've got 5 options here, 6 options here, so total that's 11 options. And then D is both numbers are even. So this is going to be similar to both numbers are odd. If we count all those up, 1's aren't going to work, 3's aren't going to work, 5's aren't going to work. There's going to be 3 options in each of these even columns, so that one's also going to be 9, just like both numbers are odd was 9. All right, so find the probabilities. So biggest thing to remember with probability is we're always going to have it over our total, which we figured out is 36. So the probability of event A happening, we figured out there's 6 ways for it to happen, so the probability would be 6 out of 36 total ways, or that equals 1 out of 6. Okay, so now we get into the multiple events. So what's the probability of B and C happening? So we talked about whenever we have an and situation, we're always going to find the individual probabilities and then multiply them. It's going to be the multiplication of the individual probabilities. So the probability of B happening is 9 ways out of 36. There's 9 ways that event B could happen, and there's 36 total possibilities. And then I'm going to multiply that by the 11 ways that C could happen out of 36 total ways. Oops, 11 out of 36. So I'm just going to take the probability of each individual event, and then I'm going to multiply those two numbers together. So if I plug that in, 9 over 36 times 11 over 36, and reduce the fraction, we get 11 out of 144. So this would be our probability of B and C happening, of both the numbers being odd and 3 being one of those numbers. All right, probability of B and A. So again, probability of B is 9 out of 36. probability of A was 6 out of 36. So again, since it's and, we multiply those together. 9 out of 36 times 6 out of 36. When we multiply it and reduce it, it turns into 1 out of 24. All right, fourth one, probability of not C. So that means C does not happen. So 3 is not one of the numbers. Well, if the probability of C happening was 11 out of 36, then the probability of C not happening is whatever's left over after I take those 11 choices out of the 36 options. So if I take 36 minus those 11 options, I get 25 options. So there's 25 ways for C to not happen, since there's 11 ways that C can happen, and there's 36 total options. So the probability of C not happening would be those 25 ways that it doesn't happen out of the 36 total possibilities. All right, and finally, B or A. Okay, so we haven't done an OR statement yet. So OR is where we add the probabilities together, and we also have to subtract any overlap. So we'll talk about what that means. So event B is both numbers are odd. Event A is that you get a pair. So the individual probabilities, B is 9 out of 36, which we've talked about. A is 6 out of 36. Okay, so we have to add those together, but we also have to subtract any overlap. So overlap means when both of those things happen. So both the numbers are odd and they're a pair. So our pairs, there were 6 pairs. We had 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. 3 of those options, 1, 1, 3, 3, and 5, 5, fit both A and B. Okay, so they're a pair. All of these are a pair, and both the numbers are odd. So this is our overlap. Okay, events that fit both of the events that we're talking about. So this is our overlap. We have 3 things that overlap. So we have to subtract that. After we add the individual probabilities, we have to subtract that. Okay, so we have all of our denominators are 36 because those are all of our probabilities. So we have 9 plus 6 minus 3. So altogether, that's going to be 12 out of 36, which is going to reduce to 1 out of 3. So the probability of B or A happening is 1 out of 3. All right, on the next page, we've got the following frequency distribution analyzes the scores on a math test. So there were 2 students that scored between a 40 and a 59. There were 4 students that scored between a 60 and a 75. 6 scored between 76 and 82. 15 between 83 and 94. And 5 students scored between a 95 and a 99. So if we add all these possibilities up, there were 32 total students that we're talking about. So that number is going to be important when we're talking about probability. The total was 32. So those are all our possible outcomes. So if we select a student at random, find the probability that a student got at least a 76. So that means they got a 76 or higher. It says at least a 76. That means 76 is the minimum. They could have gotten higher than that. So we want all the scores that were 76 or higher. Well, these 6 kids got between a 76 and an 82. So those would work. And then we want to figure out all the kids that scored higher than that. So these 15 kids scored higher than that. These 5 kids scored higher than that. So if we add all of those up, all of those kids out of the 32 total kids scored higher than a 76. So if we add 6 plus 5 plus 15, we get 26 out of 32, which then reduces to 13 out of 16. So the probability that the student got at least 76 is 13 out of 16, which is a pretty high probability. All right, and number 2, probability that the student got between an 83 and a 99. Well, all of these students got between an 83 and a 99, so we add 15 plus 5, which is 20 out of those 32 students, and when we reduce that, it gives us 5 out of 8. So the probability would be 5 out of 8. All right, probability that the student got either at most a 59, so that means 59 or lower, or, this is important, at least a 76. So we already know the probability that the student got at least a 76 was 13 out of 16. Okay, and as we talked about on the last page, an OR statement means that I add the individual probabilities together and subtract any overlap. Well, for this problem, there's not going to be any overlap because there couldn't be a student that fits both these categories. They can't have lower than a 59 and higher than a 76. So just based on the way the problem is written, there's not going to be any overlap. So the probability that they got at most a 59, so a 59 or lower, there were 2 students that got a 59 or lower. So I would take the 2 out of 32 and add the 26 out of 32, or it reduced to 13 out of 16, so 26 out of 32. It's easier if I take it unreduced to add it, so that gives me 28 out of 32, which reduces to 7 out of 8. All right, and last example. So we've got, in a competition, 2 people will be selected from 4 finalists to receive the first and second prizes. So, as we talked about in the last section, when it says first and second prizes, the order does matter. So picking person 1 and person 2 is different than picking person 2 and then person 1. The prize winners will be selected drawing names from a hat. 4 finalists are Jim, George, Helen, and Maggie. List all the possible outcomes. So let's start with Jim. Jim could be first 3 different ways, because George could come in second, Helen could come in second, and then Maggie could come in second. Or George could be first, Jim could be second, Helen could be second, or Maggie could be second. Or Helen could be first, Jim could be second, George could be second, Maggie could be second. Or Maggie could be first, Maggie first, Jim, George, Helen. So adding all those up, we've got 12 possibilities. Okay, so let the events be as follows. Event A, George wins second prize. Well, he wins second here, here, and here. So there's 3 ways George could win the second prize. George and Helen both win a prize. George and Helen won here, and George and Helen won here. Either George gets first or Helen gets first, and the other person gets second, so that's only 2 possibilities. Maggie wins first. There's 3 ways that Maggie wins first. Maggie wins second. There's also 3 ways that Maggie wins second. Here, here, and here. All right, so we've got our numbers. So find the probability of A happening. Well, there's 3 ways it could happen. There's 12 total possibilities. So 3 out of 12 is 1 out of 4. Probability of A and B. That means we're going to multiply the probabilities when we have an and situation. So probability of A, we just figured out, was 3 out of 12. Probability of B, there's only 2 ways for that to happen out of 12 total ways. So 3 out of 12 times 2 out of 12 gives us 6 out of 144 when we multiply straight across, and then when we reduce it, it's 1 out of 24. Probability of C or D. Or means we add the probabilities and subtract any overlap. So let's see if there's any overlap. Probability of C is Maggie wins first. Probability of D is Maggie wins second. There's no way that Maggie could win first and second, so there's not going to be any overlap there. So we don't have to worry about overlap. So probability of each of those, there's 3 ways she could win first, 3 ways she could win second, so probability of each is 3 out of 12. So if we add those together, 6 out of 12, or 1/2. Probability of B happening, we've already sort of done this. 2 ways for that to happen, 12 possibilities, 1 out of 6. Probability of not D or not C. So let's see, not D. So probability of not D happening. Well, there's 3 ways for D to happen, which means the other 9 possibilities is that D doesn't happen. Maggie doesn't win second. Probability of not C, again, there's 3 ways it can happen, which means there's 9 ways that it can't happen. If she doesn't win first, then there's 9 other possibilities for people to win. So probability of each of these is 9 out of 12. We add them together. Let's see if there's any overlap. If Maggie wins first, then that means that she can't win second. So the 9 possibilities where Maggie doesn't win first are all here. But in these 3 possibilities, Maggie won second, so that would be overlap. Same thing, in these 9 possibilities, Maggie does not win second, but in these 3 possibilities, she did win first. So those 3 overlap, and these 3 overlap means we have 6 total events that are overlap. So we have to subtract those 6 out of 12 events from our total. So adding all that together, 9 plus 9 minus 6, we would get 12 out of 12, or a 1 probability, which means a 100 chance that that's going to happen.